Okay. So, all right. So we're on 2.3. Sorry, I just started recording. Okay. So here's our two-column proof. What is the reason that angles 2 and 3 are congruent? Well, we know the lines are parallel, and the alternate interior angles postulate said that as long as the lines are parallel, then the angles are congruent. So our reason for this is going to be the alternate interior angles postulate. Okay, and I'm abbreviating here because we have a lot of writing, so you can abbreviate too as long as you know what the abbreviations mean. Okay. So Vadim, I'm just going to keep picking on you. After you set 2 and 3 equal to each other, what was your next line of reasoning?
Angle 2 is supplementary to angle 1.
Okay, so what I'm going to say is angle 1 plus angle 3 equals 180 degrees. Okay? And
Angle 2 first.
or sorry, wait, 2. Yeah, sorry, 2. Thank you. I'm getting ahead of myself. So angle 1 plus angle 2 is 180 degrees, and the reason why that is those two angles are called a linear pair. So the reason there is a linear pair. All that means is that they create a line, and if you ever forget what a linear function is like, it is like a linear function. Linear, yes, so it's a line. Okay? I should take that time out of these stories. That's really not good. You would want to get another. Okay? So, Vadim, you said that 1 and 3 are supplementary. Okay? So I'm going to say angles 1 and 3 are supplementary.
You said 1 R.
No, I didn't.
Yeah, you did.
Where?
Right there. Under that word.
Yeah, I changed it there. So, okay, and here's the thing. We already wrote that angle 1 plus angle 3 equals 180 degrees, so it feels a little redundant to write that they're supplementary, but this is what you need to do in two-column proofs. You have to be very precise, okay? So angle 1 and 3 are supplementary. The reason for that is we call that the definition of supplementary angles, okay? So that's the definition.
Can I just abbreviate it, or just write the whole entire thing out?
If you write depth of sub-angles, that's fine.
Okay, that's exactly what I'm doing.
It sounds like death of supplementary angles, which sounds like a rock band.
Like Def Leppard and the Def Code.
Yeah, exactly. Okay. So Vadim, yes.
Do I look anything like me?
Yes.
Wait, 1 and 2. Gosh. Okay. Sorry. I keep writing 3. You should have angle 1 and 2 are supplementary.
Oh, I was wondering, like 3.
Like, how did Mr. Thesing know that? No. It's 1 and 2. Sorry. I keep writing 3.
Well, it's like my because
So please make sure, pay attention. If you wrote 4 down and you didn't pay attention for about the last 10 seconds, it's angle 1 and angle 2 are supplementary. Okay? I accidentally put 3. Okay, Vadim, what was the next thing you said?
Angle 2 and angle 3 are congruent.
Angle 2 and angle 3 are congruent. Okay? So we had that. Yep, we already got that. So now what are we going to say?
So since they are congruent, angle 3 is supplementary to.
Good. So before we do that, let's see on step 2 here. In step 3, we have 2 is equal to 3 and 1 plus 2 is 180. Since 2 is equal to 3, let's say angle 1 plus angle 3 equals 180 degrees.
Are you sure that's supposed to be angle 3?
That is, yes. So I'm now substituting, instead of 2 here, I'm going to put a 3 here. Okay?
These are ridiculously long.
They are. And this one is called the substitution property. Okay? So 1 and 3 are 180. Now, what was the exact statement that we were trying to prove?
1 and 3 are whatever.
Angle 1 and 3 are supplementary. Okay, we're basically there, right? What is step 6 going to be?
1 and 3 are supplementary.
And the reason is,
1 plus 3 equals 20.
so 1 and 2 are supplementary. You're right. It's called the definition. That is the definition of supplementary angles. Okay. So the 2-column proofs are just kind of, they're nitpicky. They're really tedious. So, but you have an airtight proof. Nobody's going to disagree with you on this. Okay. So angle 1 and, well, yes, Zane. Yeah, he probably would.
That's wrong.
So angles 1.
You just disagreed on
Point
that.
and case. So angle 1 and 3 are supplementary, and that's going to be the definition of supplementary. Because we're very clear.
Oh, battery, but the face thing is gonna die soon. Just like me.
Wow.
That would. That's pretty impressive.
Roseanne, you watched that? You watched the video?
Ralph,
You're the only voice that can hear.
Good.
Like,
That's all I needed here.
Clear. Okay. So did we? Let's bring it together. Bring it together. Bring it together. Did we show what we want to show?
Yes.
Our last statement was what we want to show. So we're good. Okay. That's called a 2-column proof. We will do some of those. We won't do a whole lot because I feel like what I want you guys to get is to know how to actually use the logic, not how to write the pretty columns. And the reason, you know.
Is it gonna be on like?
You will.
On the test?
I'm not sure if I'll make you make one of these. I might make you interpret one though. Like I might make you look at one that's already written.
Oh yeah, that helped me a lot.
Okay. And on your homework tonight, we have some of those. Okay. So yes, really. Okay. So that's that. Is anybody still writing? I think we're good. Yes. If you are like second period, most of you will finish it.
Exactly.
Okay.
Yeah, why are you always comparing us to second period?
Because
You
we're
don't like us
better.
anymore?
You guys actually did better than
You
second
like us
period.
back because you
So-
want to give us homework on the weekend.
You know the reason why we're better than second period though? Because you got Zane.
So I got to keep moving here because I'm getting yelled at. Yes.
That was relatively why whoever just said that. I'm really proud of you.
Like 1 equals 2, 2 equals 3, so 1 equals 3. That's called the transitive property. Okay, so we've got some different methods of proof. One of those, a 2-column proof, it's really tedious and you have to write out all your definitions and stuff. Another one is a paragraph proof. I personally like this one a little more because all you do is write down what you would tell me out loud. So what did Vadim say? Vadim, can you walk me through the steps on our 2-column proof again? So
Since we know that M is parallel to N, do I have to say the reason as well?
it was given.
If so.
So we'll just say since M is parallel to N.
Then angle 2 is congruent to angle 3 because they are alternate interior angles. Do I have to say the postulate?
I'm going to put it in parentheses, okay? Okay, alternate interior angles postulate. Okay, so keep going.
Angle 1 and angle 2 equal 180 degrees because they are supplementary.
I'm going to put so they are supplementary. The nice thing about the paragraph thing is that you don't need to be like, because this is the definition of supplementary. You can just say angle 1 and 2 equal 180 degrees when you add them up, so they're supplementary. Okay.
And angle. Wait, so they equal 180, so they are supplementary.
Yep.
And then angle 1 and 3 are 180 degrees because angle 1 and 2 are congruent.
Good. So let's think of a nice good way to say this.
So
Were you gonna?
Since angle 2 is congruent to angle 3, angle 1 is
Angle 1 what? Angle 1 plus angle 3 equals 180. Yeah, they're not congruent. So since angle 2 is congruent to angle 3, then angle 1, here's what I'm going to write. You ready? Angle 1 plus angle 2 is equal to angle 1 plus angle 3, and that's equal to 180 degrees.
Yes.
Yeah, you would need to write something like this. If yours was different by a few words, it's okay as long as you get the logic
Our
right.
notes.
You're in my way.
Sorry. Okay. So we would need to say what? So angles angle 1 and angle 3 are supplementary. Okay.
Okay, wait. So
I'm gonna say that's all we have to put for that one. It is kind of a lot, but that's all we have to put. We've got one more proof type, and then we'll be done with this.
Then can I go to the restroom and get me a better?
After we're done with this part. Okay. Any questions on this?
No.
All right. So the last proof that I want to talk about. So the flow charts were listed on here. We'll see some of those later. Okay. All the flow chart is this like little, like when people draw pictures and they put like a little cloud thought by a person. That's kind of what the flow chart is. It's like here's what you're given. M is parallel to N. The next thing you think is angle 2 congruent. It's basically writing this, except with like little bubbles. Yes.
Our homework from yesterday, are you going to go over that?
Yes. Let me finish this, and then we can go over the homework from yesterday. Yeah.
Did you check homework already?
Yes, I did. Yes, if you guys haven't seen it. Okay, so an indirect proof. I'll let you guys write this, and then give them points. So an indirect proof is a really clever way of winning an argument. And I will let you guys write that down and then explain. And I will explain. So write this down. You should be writing, not talking. Very good.
I forgot how to write. Given the algorithm is reducing.
You should be writing.
I am writing. I can read. I can multitask.
You should be writing,
I am writing.
Naomi. You should be writing, Naomi.
I'm writing. Never. How'd you do it?
Lots of practice.
Can you do it that big one, the small one? Can you do that one?
The 2x2 I can do.
Can you do it one by one?
Everybody can do it one by one.
I can't do it by the 2x2.
The fastest time for one by one is 0.007 seconds.
The fastest time for this is like 8 tenths of a second.
Yeah, I think my friend Jared can do that easily. He does those for fun. Well, he does the like big 7-second ones for fun though. He gets upset. And he tried to show me how to do it. I don't follow it all. I just laugh at him.
All right. You guys still ready?
Yeah, I'm at home.
Okay.
You know he favored my
He doesn't care if it's red because they can't. No, Gus's.
He favored my team.
My friend Jared.
There's a picture.
I know his brother.
He favored Can you scroll down?
Here you go, Naomi.
Can I see real quick?
One more note. Okay. I haven't. There's nothing below here yet. I'm gonna write it down. Okay. So, are we good? So, indirect proofs are a really interesting way to prove an argument. So check this out. This is really cool. I mean, I think it's really cool. I hope you guys do too. So sometimes you have something that you want to prove that you don't quite know how to exactly prove the statement. So let me ask you this. What would you guys say to prove that if two numbers multiplied equal a non-zero number, then neither of those numbers was zero? Like, how would you... Well, first of all, do we even agree with that?
Yes.
Yes.
Can I say the answer?
What would you say?
Agreed, because any number times 0 equals 0.
Okay.
Where the answer can't be 0, and the two numbers can't be 0. That multiply together.
Good. So you're actually using exactly what I'm going to show you guys. You're doing it. You're doing a proof by the contradiction. So that's good. I'm wondering if you can just use.
Yeah.
You're correct. I'm wondering. Yes.
So 0 doesn't go into any number of times. 0 doesn't go to a non-zero number any number of times.
Oh, okay. So you guys are following the same line of reasoning. Yeah. Good. So this is kind of hard to just prove without using circular reasoning, and because you could just say, well, if two numbers multiply to equal a non-zero number, then neither of those numbers is 0. Well, duh, that's obvious. Okay. Maybe that's obvious to you, but it's not necessarily obvious to everybody else. So you have to provide a convincing proof. So let me basically say what these guys said, what Baja and Zane said, as a convincing proof. And this one's an indirect proof because it proves something different. All right. So you ready for this? I find this fascinating. What we're going to do is we're going to assume that this statement is false. And then we're going to show that it leads to something ridiculous. Okay? So we're going to assume for a second, we'll just, for the sake of argument, we'll say, maybe it's true, maybe it's not. Let's just assume it is, that it's false. And then we're going to show that it leads to something absurd. And in Latin, they call this a reductio ad absurdum argument, a reduction to the absurd argument. You ready? Let's assume, on the contrary, that two numbers multiplied You should be writing. So let's assume, on the contrary, that two numbers multiplied together and made a non-zero number, but one of them was 0. Okay? So Baja, what we did was we assumed that this was false for a second. We're going to show that that's ridiculous. It's impossible. So what that means is, as long as we can show that the opposite is ridiculous, then we know we're right. Okay? So two numbers multiplied together and made a non-zero number, but one of them was 0. So what we're going to do is we're going to say, okay, let's multiply our two numbers together. Then if we multiply our two numbers together, 0 0, and x. Let's just make x the other number, okay? We don't know if x is 0, positive, negative, if it's big, it's small, whatever. Okay? It's just some number, okay? Then if we multiply our two numbers together, we get 0 times x is 0, right? What's the problem here? I claim that there's an issue going on. So we assumed that we took two numbers and multiplied them together and we got a non-zero answer. Okay? And the claim is that neither one of them is 0. Okay? So what we said was, all right, gentlemen. So the original statement that we're trying to prove is all the way up here, right? If two numbers multiplied equal a non-zero number, then neither of those numbers is 0. So what we did was we were like, all right, let's just assume that that's false for a second. And then we're going to show that that logic leads to a contradiction or something that doesn't make sense. And as long as that thing, the conclusion doesn't make sense, then we know it must be true. Okay? The original statement must be true. So we assumed, on the contrary, that two numbers multiplied together and they made a non-zero number. Okay? But one of them was 0. So we're saying, let's suppose, on the contrary, that when you multiply them together, one of them was 0. Okay? What happens?
Sorry, you're supposed to like contradict the original statement.
Exactly. So what's going to happen here is, notice how we multiplied our two numbers together and we got 0? What was the original assumption when we multiplied our two numbers together? That when you multiply them together, what did you get?
Non-zero number.
They made a non-zero number.
Well, actually, that would be true if
Oh,
x
so
equals 0.
So you're just finding out how you can just like
Right?
get rid of the. I just
What's
think
true?
it's Zero. It's zero.
See?
If x equals 0, then
It said
it wouldn't
two.
equal
It
0.
said two numbers. It specified.
0 times 0 is 0.
Specified.
If you put a 0 in for x, you still get 0.
Okay.
When you multiply.
No, you're done.
I
That's
think
done. Yes.
Not yet. We're close. I'm glad you see. So what's the problem here? But
how many zeros go into 0?
this contradicts our assumption. This contradicts our assumption that, yeah, it is.
I wrote more in here than in my English class.
Yeah.
This contradicts our assumption that when we multiplied the two numbers, we got something non-zero. Yep. Trust me, if you guys study math in college, you will have to write proofs that are like 2, 3, 4 pages long.
Don't
I
worry.
got one problem.
All right.
Wait, I've got one problem.
All 4 years.
Prove once that's what he was
College now.
All
A lot of people don't have to even take that.
Really?
Why?
It depends on what you want to major in.
What about
interior designing?
You'll have to ask Miss Hemp or Miss Mac. They would know that. I don't know. If you're like a science person, you're gonna have to take a lot.
A lot of it. Like everything.
Okay, so let's finish this and then we can talk. Okay, let's finish this first. So let's walk through the proof again. Okay. So what are we trying to prove? Okay, gentlemen, shh, pay attention. Even if you've got it, I know you need to pay attention so other people can get it. Maja, you guys ready? Okay. Are you guys ready? Okay. We're trying to prove, okay, if two numbers multiply to equal a non-zero number, then neither of the numbers is 0, okay? What we did was we were like, all right, let's suppose for a second that that's not true. Let's assume that we do have two numbers that multiply together and make a non-zero number, but one of them is 0.
Wait,
Okay.
non-zero numbers like 1, 2, 3, 4, 5, 6.
Anything that's not 0. Yep.
Wait.
so we're going to assume on the contrary that two numbers did multiply together and made a non-zero number, but one of them was zero. Okay, so we're going against what our original assumption was up here. Okay, what happens then? Well, if we multiply our two numbers together, 0 and x, x is just another number. I don't know what it is. It doesn't really matter. If you multiply them together, look, you get 0 times x, which is 0. But what's the problem? We assumed that our two numbers multiplied together
Would make it non-zero.
and made a non-zero number. Did our two numbers multiplied together here make a non-zero number?
No.
So that contradicts, this contradicts our assumption right here in the red that when we multiply the two numbers together, we get something non-zero. Therefore, and here it is, you ready? Therefore,
It is wrong.
it must be the case that
That's what we
if,
want to test.
yes, that if two numbers multiply together to create a non-zero number, then neither of them is zero. Yes.
So basically, what we do is find an example that proves it wrong, and then write down why we proved it wrong.
Yeah, so what you do is, let's assume you and I are having an argument, and I'm saying something. You're like, all right, I think that you are wrong. So what you do is you say, I'm going to make the same assumptions that you made, Mr. Thiesing, and I'm going to take your argument and walk it out to its conclusion. Okay?
That's a smarter move.
What you can do, Baja, and let's say that you're right. I think I'm right, but I'm not. What you do is you say, all right, Mr. T, I'll take your assumptions and let's see what happens. In this case, we got 0 times something equals 0, and it totally contradicted our original assumption. You take my statements and then you walk to the end of the conclusion. What you do is you're like, oh, but look, Mr. T, you said that this would never happen, but check it out, it happened here. So your argument is completely wrong. That's what you would say to me. And then what you can do is say, you must be wrong, so I must be right, if we disagree about something. In logic, in math, you can do that. It doesn't always work that way in marriage. I'm just going to throw that out there.
It's either you're wrong
But
or you're
in
wrong.
math, if you and somebody else disagree on something, like let's say you're saying A and I'm saying not A, as long as you can show that I'm wrong, then you guarantee that you're right. Okay? So yes, this is a very sly way of proving somebody either right or wrong by taking their argument and letting it go to its conclusion, and then being like, that's ridiculous. Like this conclusion that you arrived at totally contradicts everything that we assumed earlier. Yes.
What if you don't find something that contradicts their...
So that's so if you try to do, this is called a proof by contradiction, okay, or a reductio ad absurdum argument. If you can't find anything that contradicts, then you're in trouble because their argument might actually be right.
So how would you prove them wrong?
So here, this is an interesting situation. Let's say Baja and I were arguing about this, okay? Do you want to? Which one do you want to take, Baja? Do you want to take this or?
I'll take on yours.
So let's say Baja's right. She, not in this period. She is in my life. She was. Did I mark that?
No, she was marked absent for this period. So.
Okay. Oh, thanks. I wonder if she's late
Double check. Thank you.
to wellness. Yep. Okay, so let's say Baja is taking this, this stance, and I'm like, no way. Like, if two numbers multiply to equal a non-zero number, then it's not the case that neither of them could be zero. I'm saying maybe one of them is zero. Baja's like, all right, let's roll with that. So She's going to say, all right, Mr. T, let's assume that you have two numbers that you multiply together, and they're non-zero, so maybe they equal 8 or something. She's like, but what you're saying, Mr. T, is that one of them is 0, or maybe both of them are 0, who knows? She says, all right, Mr. T, if we multiply your two numbers together, so one of them's 0, okay, we get 0 times x is 0. But the way that Baja wins this argument is she says, but look, Mr. T, this contradicts your assumption that when you multiply the two numbers together, you get something non-zero. That was the original assumption. Okay? And so my argument contradicts itself, which means she must be right.
That's a lot.
So are we done now? Is it done deal?
So we were wrong. Yeah, he was wrong.
So I was wrong. Baja is correct to say that if two numbers multiply together and they get something that's not 0, then there's no way either one of them is 0.
So you would have to try to prove yourself, right?
Baja would. I would have to try to prove myself, but what happens when I try to prove myself? I get two things that completely contradict each other. At first, I'm like, all right, so I have two numbers that multiply together that don't make 0, but one of them is 0. And Baja's like, but Mr. T, look, if you do 0 times x, it's 0, which is 0. Which contradicts your assumption that your two numbers didn't multiply to give you 0. So you must be wrong, Mr. T.
So this is done now, right?
Yes, we're done.
Thank you. Thank you, John.
Okay, this is if you're kind of like, what the heck is going on here? Don't worry, it can be a little hard to understand the first time. I had to take an entire course just on writing proofs like this, so I don't expect you to get it necessarily in the first 10 minutes. Okay, if you still feel a little lost on it, you should ask me though, and I can help explain it. I'm not going to keep belaboring the point. I'm going to go ahead and give you guys the homework. You want me to scroll up a little bit? Did everybody copy this? You want to go like right to the graph? To there? The two-column proof? So that's called a proof by contradiction. It is extremely powerful if you know how to use it. All right, the homework. I thought we already had this conversation. You guys should be able to finish it.
The whole speech you know,
So you're once you listen to it, I want you to listen to it.
Why would you say that?
Oh, okay, cool. I was just where did I find their papers? I can only find like 8 of them. I'm glad you guys found it. We're gonna learn that. So here's the thing. I've heard this all this morning. I didn't realize that I have ASA, SSS stuff on it. Don't worry about those. Finish the rest of it. Ask me about it. We're gonna learn that one. ASA. Yeah. So like that one, don't worry about it. Yeah. That's what I'm just trying to
We need one more.
that means that BD is perfect.